By 2026, tech won't just change how we live. It could change whether we survive. Some could extend human life. Others could transform our planet or even threaten it. Let's count down 14 technologies already in development. Starting with number 14, a breakthrough that pulls electricity right out of thin air. Number 14, converting air humidity to electricity. Researchers have created thin, flexible membranes that generate electricity from moisture in the air. Built using protein nanowires from Geobacter sulfur reducens, these films continuously produce low-voltage power without batteries or sunlight. Early prototypes power ultra-low energy devices, and lab results suggest scalability for wearables, sensors, and remote systems. Because the material is compostable and requires no moving parts, it could power electronics anywhere human air exists. While still in development, it's a major step towards fully distributed renewable power. Energy drawn passively from the environment without traditional grids, storage, or fossil fuels. Number 13. Mapping the universe in real time. In June 2025, Vera C. Rubin Observatory captured its first ultra-deep images using the world's largest digital camera, 3.2 gigapixels. In its first 10 hours, it identified over 2,100 previously unknown asteroids. Starting late 2025, it'll scan the southern sky every few nights for a decade, tracking supernovas, asteroid orbits, and potential Earth impact threats. Scientists expect to detect around 20 billion galaxies and more than 100,000 near-Earth objects. By producing a continuous time-lapse movie of the universe, it'll transform planetary defense, astronomy, and our understanding of dark matter and dark energy in unprecedented detail. Number 12. Artificial photosynthesis. Artificial photosynthesis mimics nature's process but at higher efficiency. Using sunlight, water, and CO2, experimental devices produce liquid fuels, plastics, or industrial chemicals. Some pilot plants already capture CO2 from air or industry and convert it into carbon-neutral jet fuel. Unlike natural photosynthesis, these systems can operate year-round in scale for industrial use. Researchers see potential to decarbonize aviation, shipping, and manufacturing while reducing atmospheric CO2. Number 11. Programmable matter and shape-shifting devices. Researchers are developing programmable matter materials that can change shape, texture, or even function on demand. Early prototypes use microactu, magnetics, or responsive polymers to alter their physical state in seconds. A single device could morph from a flat sheet into tools, drones, or components without traditional manufacturing. In robotics, this could mean machines that adapt their form to their environment. Military and space applications include equipment that reconfigures in the field. While practical consumer versions are years away, experiments in soft robotics and reconfigurable materials show how physical objects may soon be as editable as digital files. Number 10. Organoid intelligence. Organoid intelligence uses lab-grown clusters of human and animal brain cells, mini-brains, to process information. Unlike silicon chips, these living neural networks learn and adapt using biological efficiency. Researchers have trained organoids to control simple computer tasks and respond to stimuli. The appeal is energy efficiency. A human brain uses about 20 watts, far less than AI supercomputers. Potential applications include ultra-efficient machine learning systems or hybrid biological digital processors. The field also raises ethical debates about sentience and consciousness in lab-grown tissues. Current research focuses on improving training methods and scaling neural capacity without crossing ethical or legal boundaries. Number 9. Fully autonomous AI agents. Fully autonomous AI agents are systems that operate without direct human input, setting their own goals and executing them end-to-end using natural language interfaces. They can manage research, code software, trade stocks, or oversee supply chains independently. Unlike traditional AI tools, they adapt to changing conditions in real time. Prototypes like AutoGPT and Devon have demonstrated limited autonomy, but enterprise versions are in testing for 2026. Potential risks include decision-making, transparency, security vulnerabilities, and the possibility of agents pursuing unintended objectives. As autonomy improves, oversight mechanisms will be critical to prevent harmful or uncontrolled outcomes. Number 8. Extreme environment robotics in fast learning machines. Robots are being built to master tasks in minutes rather than months. Using advanced reinforcement learning, they adapt quickly to new environments. Models like Figure 02 and Agility Robotics Digit are entering industrial trials. While deep-sea and nuclear site robots undergo extreme condition testing, these machines operate where humans cannot, under high radiation, deep underwater, or in space. Fast learning capability reduces costly retraining and downtime. In 2025, prototypes demonstrated assembly tasks learned overnight and autonomous navigation in hazardous terrain. As capabilities improve, these robots could handle disaster recovery, exploration, and defense missions without exposing humans to life-threatening risks. Number 7. Large-scale LEO satellite internet. Mega constellations like SpaceX's Starlink and Amazon's Project Kuiper are deploying thousands of satellites in low Earth orbit to deliver high-speed internet globally. As of mid-2025, Starlink operates over 6,000 satellites, reaching more than 75 countries. These networks aim to connect remote regions, ships, and aircraft without terrestrial infrastructure. They also expand capabilities for Earth observation, disaster response, and defense. However, concerns include orbital debris, space traffic management, and geopolitical control over global communications. By 2026, coverage and capacity are expected to expand sharply, reshaping access to information worldwide and influencing both civilian and strategic communications. Number 6. Sustainable aviation fuel from air and waste. Sustainable aviation fuel SAF made from captured CO2 and renewable energy is moving from pilot to industrial scale. Processes like Fischer-Tropsch synthesis use atmospheric CO2 or waste gases combined with green hydrogen to produce liquid hydrocarbons compatible with existing aircraft engines. In 2025, plants in Europe and North America began producing small but commercially viable volumes. Airlines, including United and Lufthansa, have conducted successful test flights. If scaled, SAF could significantly reduce aviation's carbon footprint while reusing atmospheric carbon. Cost, production volume, and renewable power supply remain challenges. But the technology is advancing toward a larger scale deployment. Number 5. Quantum AI. Quantum AI merges quantum computing's processing power with machine learning's adaptability. Quantum processors can explore many possible solutions simultaneously, making them suited for optimization, drug discovery, and complex modeling. In 2025, IBM, Google, and startups like Quantum reported progress in error correction, critical for stable quantum operations. While most work remains experimental, quantum-enhanced AI could eventually outperform classical AI in chemistry, logistics, and cryptography. A major concern is cybersecurity. Once mature, quantum systems could break current encryption standards. Governments and companies are already working on quantum-safe cryptography to prepare for that eventual capability. Number 4. Self-growing engineered living therapeutics. Living therapeutics use engineered cells or microbes that function inside the body to detect and respond to disease in real time. For example, engineered gut bacteria can sense inflammation and release anti-inflammatory compounds. Trials are exploring treatments for diabetes, cancer, and metabolic disorders. Unlike traditional drugs, these systems persist and adapt over time, potentially replacing failing biological functions. Researchers are also developing programmable cell therapies that can be updated like software. Early studies show promise, but long-term safety, control, and immune responses are still under review before widespread clinical use. Number 3. Implantable brain-computer interfaces. Brain-computer interfaces. BCIS link the brain directly to computers for two-way communication. Neuralink, Synchron, and other companies are testing implants that allow paralyzed patients to control devices by thought. Implants record neural activity and can stimulate brain regions to restore function. Potential applications include memory augmentation and direct brain-to-brain communication. In 2025, human trials expanded to more patients, demonstrating reliable cursor control and text generation purely via thought. Key challenges include surgical risks, data security, and long-term stability of implants, but progress is steady toward more advanced human-machine integration. Number 2. Real-time AI-driven natural disaster prediction. AI-powered systems are now combining satellite imagery, remote sensing, and weather data to predict natural disasters earlier and more accurately. Platforms like Google's Flood Hub and IBM's AI weather models can forecast floods, storms, and heat waves days to weeks in advance. Newer global projects aim to integrate seismic data for earthquake and tsunami prediction. In 2025, AI systems successfully provided multi-day cyclone alerts in the Indian Ocean and early wildfire spread forecasts in California. The next step is scaling these capabilities to regions with limited infrastructure, improving response times and potentially saving thousands of lives. Number 1. Cryogenic preservation and revival research. Cryopreservation is advancing beyond cell storage to whole organ freezing and revival. Vitrification techniques prevent ice crystal damage, enabling viable long-term storage of kidneys, livers, and other organs for transplant. In 2025, researchers successfully rewarmed preserved rat kidneys and restored function after transplantation. Long-term, this could extend whole-body preservation with potential applications in long-duration space travel and life extension research. While human revival remains speculative and far from the current capability, organ preservation breakthroughs are already transforming transplant logistics and could one day make indefinite biological storage and eventual revival possible. The future isn't decades away. It's unfolding right now, piece by piece. Hope you got a ton of value from seeing what's coming next in tech. If you made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.